I have a test to take this week and I also need to make this video, so today we're going to talk about sketching graphs, and not sketching graphs like y equals x or y equals x squared, but more complicated ones with more parts. So, step number 1, taking derivatives. And if you're asking yourself what the heck is a derivative, I have never heard of that, please, what are you talking about? Well, you're in luck because I'm going to show you what that means. So say we have a set of axes and an equation, and for example purposes we're going to use y equals x squared. The derivative is basically talking about the instantaneous slope as you are approaching a certain y value on a graph. So first things first, we have the formal definition of the derivative, and this is basically the limit definition of the derivative. So if you don't really know about limits, you might need to find another video because I'm not really going to explain that here. But basically this is the limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x, but we usually just simplify that to h because the x's cancel out anyway. So for example, if we had f of x equals x squared, the limit as h approaches 0 would be x plus h squared minus x squared all over h, and by doing some simple algebra we can figure out that this is x squared plus xh plus xh plus h squared and yada yada yada, and now I've run out of room on my whiteboard and we need to erase, so we simplify that down to x squared plus 2xh plus h squared minus x squared over h. X squares cancel out, some more things cancel out, and basically once we plug in that 0, we figure out that the derivative of f of x, or f prime of x, is equal to 2x. So that takes forever and is kind of a huge waste of time, so we have derivative shortcuts, and these pretty much just exist to make our lives easier, and I'm not going to go into all of them because frankly that would take forever. So anyway, back to sketching graphs. So the first derivative is referring to the slope of your original function. The second derivative is referring to the slope of that slope, or in relation to your original function, the concavity or concativity if you watch Khan Academy. F prime of x, the slope, can be positive or negative, and when it is positive, that means your graph is increasing. When it is negative, your graph's decreasing. So, for example, using the equation f of x equals x squared, we can see where it is negative and where it is positive. So where it's increasing and decreasing, and the point where this changes is where the slope is equal to 0, which brings us into critical points. Critical points are where the derivative, or the slope, f prime of x is equal to 0 or does not exist, and this is where your graph gets a little weird. So f double prime of x, or the concavity, can also be positive or negative. Where it's positive, that means it's concave up. When it's negative, that means concave down. Or it can also have zero concavity, who knows. And this mostly happens with linear equations. And you can also have critical points with these. So this is where the concavity, or f double prime of x, is equal to 0 or does not exist. And with critical points come points of inflection. And this is pretty much exclusive to concavity, and this is where it changes. So, given this graph, f of x equals x cubed, we can see where it's concave up, concave down, and the point of inflection where that changes. So, again, back to sketching graphs. Once again, this isn't really with simple equations like f of x equals x, which we pretty much know off the top of our head, or even x squared, which we can sketch out pretty simply without much thought. It's for more complicated ones with more parts and variables. So for example, f of x equals 3x squared plus 9x plus 6. We might not know how to sketch this out right off the top of our head, and plugging in numbers and figuring that out just takes way too long, and we just don't always have time to do that. So first things first, we'll find the slope. And this is the first derivative, so f prime of x, so we have 6x plus 9 plus 0, but we can just get rid of the 0 because it doesn't do anything. And this tells us where the graph is increasing and decreasing. And we can lay this all out using a sign chart, and this is just an easy visual way of figuring out where the graph is increasing and decreasing. So we do this by finding where the derivative is equal to 0, and by doing some math we determine that it is at negative 3 over 2, and we pick a point to the right and a point to the left. And we figure out that by plugging it back into your derivative where it is positive and where it is negative, and we can see that negative 3 over 2 is where it changes. So we can also find the concavity. So we use our original derivative to find that, and we find that it's at 6, and we can draw out a sign chart for that as well, but it's never actually going to equal 0, and there's no critical points and no points of inflection, so it'll just always be concave up. So if we draw out our axes, we can see we have negative 3 over 2, and we can go back to our original function to figure out where it would cross the x-axis by figuring out where the original function is equal to 0. So that would be at negative 1 and negative 2. And this just makes our graph a little bit more exact, and we can draw that out, and yeah, no, it doesn't look great, but who knows. So anyway, we can see where it is decreasing, where the slope is equal to 0, where it is increasing, and we can also see pretty easily that the whole thing is concave up, which matches our sign charts that we drew earlier. So anyway, that is the end of this video, and thank you for watching.